Hello and welcome to another video. In this one we're going to talk about the worst repository I've ever seen. I mean, this is only slightly hyperbole. I've seen some that are worse, but this is the worst one that I've worked on. And specifically how I rewrote its history to fix these problems. And I'm going to show you all the scripts that I wrote, all of the research that I had to do, and all of the steps that I put in place to prevent it from regressing in the future. Without further ado, let's jump into it. Okay, so the repository that we're talking about today is the Rebasing repo. This is a project that I'm sort of working on through the university, and this is the old version of it before it got rewritten. And when I started this project, this repository was, I believe, 640 megabytes. Let's see. 322, was it 7 or 3229, or is it 2337? Shoot, I'm gonna have to actually search for this issue. Dang it. Oh no, there it is, 3226, perfect. When I started this repository, or started looking at this, I noticed a few things. First, that the Git repo had 5 roots. We'll talk about that in a second. But that the repository was extremely large. It started with 628 megabytes just on a clone. This was basically, to measure the size, I basically cloned it and then did du-hs on the .git directory. This kind of represents the size of this. This is after I did the first round of oh, stop it, go away. Oh no, what have I done? Why can't I exit out of this dialogue? That was weird. Yeah, so this is after I did the first round of reduction, or after, I guess, 2 rounds of reduction. But when I started, it was 628 megabytes, which was prohibitive to cloning and working on this repository. It made it, you know, a significant barrier to entry to add developers to this project. And, you know, it was a barrier to entry to me as well, because I was like, oh, I want to change something. And I was like, great, I got to sit through a clone. I'll go get a coffee. Well, I don't drink coffee, but I'll get up and, you know, grab some slurp, and I'll be right back. But I wanted to do a couple things. First, reduce the repository size. 2, prevent it from regressing. And 3, preserve as much of the history of the current files in the repository as possible, such that it didn't lose information, or at least didn't lose information in a way that mattered. And of course, all of the history, keeping it behind in a archive that way, even though we're going to do history rewrites and destructive history rewrites, it's possible to still retrieve the original contents. So that was the goal. The first thing that I tackled in reducing repository size, or the first thing that I noticed while reducing repository size, is the branches in the repository. There was a main branch that was actively developed, and then there were hundreds and hundreds of branches that were never merged or were never actively developed. And a lot of these branches, surprisingly, a lot of these branches contain commits which introduced large binary blobs, and fortunately were never merged. So they were things where people checked in large files and didn't do anything with them. And so just off the bat, we started by deleting all branches that were older than, I picked an arbitrary cutoff of 16 days, but eventually we whittled it down to just having the primary branch and removing all of the other branches. And this significantly, right off the bat, this significantly reduced the repository size. So this was already like a pretty big win just by removing branches that didn't need to be there. Now, of course, any fix needs to be accompanied with something that prevents it from regressing. And so what did we do to prevent this from regressing? We set up a branch protection rule, which requires, I mean, there was already a branch protection rule for the main branch, but there's a new branch protection rule that prevents creation of new branches. I'm actually not sure how this one got there, but maybe this is an exception to that rule that has happened since we put that in place. But basically, prevent people from creating branches within the repository, require a fork to make a pull request. And this wasn't a big barrier to entry for developers because they're already, you know, external contributors are already forking in the first place. And so, you know, why not require our own contributors to go through the same process? And, you know, that also has the side benefit in that if we accidentally made our GitHub actions specific to the repository and not working on forks, then we would service that earlier rather than later. Okay, so that was the first thing. Delete stale branches. Cool. And prevent creation of new branches. The next thing that I noticed is a lot of the commits in the repository, and I don't really have anything to show for this. A lot of the commits in the repository were merge commits from pull requests where people made a mistake in their pull request, then fixed it. So, you know, accidentally checked in a large file, then was like, oh shit, this shouldn't end up in the final release, I'll delete it. Surely it's fine if I delete it. However, Git history is forever, so if you don't actually rebase out that commit or amend out that commit, it's going to end up in the final product. And so with a merge commit, you're still increasing the repository size. So the next thing that we did, rather than going through the painstaking process of teaching everyone a proper rebase workflow, we just forced the repository to always be squash merges. This allowed us to eliminate any intermediate stuff that people would do on pull request branches, and just have, you know, I don't want to say a nice squashed commit because I actually don't like squash merges, but for the sake of this conversation, it was a nice commit because it allowed the branches to not have all of the intermediate fluff or whip commits or accidental commits or things like that. And so that was kind of the next process, was, you know, do squash merge. That way we don't introduce accidental stuff in intermediate commits. Now the next problem, and like the main problem with repository size in general, is kind of two things. One is binary files. Git does not compress them well at all. I mean, you can't really compress binary files well at all in general, but especially in Git. So binary files are a problem, and large files. Large files a little bit less so due to the way that, you know, text compresses down a lot better, but generally you don't want large files anyway. So let's tackle those two things. The first is to prevent, you know, in this case I did prevention first, that way the prevention was in place, and then I was going to do a repo rewrite to get rid of all the other stuff. And so I took two approaches to preventing these. The first is to add a pre-commit hook to prevent binary files. Of course, there were already a bunch in the code base. A lot of these got deleted by the history rewrite, which was nice. But they're, add an allow list for everything that's already there, but then prevent things from regressing, and hopefully have a code review process in place such that people don't just, you know, cheat the list and add things to it. Of course, that happened, but details. You know, if you improve your code review processes, eventually, hopefully, someone will not regress the problem as you're trying to fix it. But anyway, so prevent binary files. This is a nice little quick. Language fail just fails if it matches anything, and there's a nice types binary in pre-commit, which matches files that look like they're binary or are conventionally binary. So like .png, it's always going to say it's a binary, but otherwise it'll have to scan for null bytes and such, or non-printable bytes. Okay, so that was the first step, prevent binary files. We also, I don't remember whether we did this or not, but we should have used check added large files as well. This prevents just large files in general. However, there were a bunch in the code base that were load bearing, so we didn't end up removing them. But this is a nice hook where you can just set a lower bound. I actually recommend setting this enforce all setting, even though it's not the default. Of course, when I wrote this hook initially, I didn't really, like, when I wrote pre-commit initially, I didn't anticipate that it would be useful in CI, or at least I didn't think about it being useful in CI. And of course, like within a couple of months after writing this, it was like, oh yeah, you kind of want something that's always enforcing all the time. And so that's where this flag comes from. But yeah, I would recommend using check added large files, prevent your repository from getting large files committed to it, even if they're not binary files, even if they're text files that are large. Again, text files that are large are less of a big deal than binary files because they compress a little bit better. However, I still aim to delete a bunch of binary files in this as well. Okay, so I guess the next thing to talk about is the crazy amount of scripts that I use to rewrite this. If you want to follow along, this is the repository that I've cloned. I believe it's archived now. And I have cloned the archived repo to this location here. So this is the old Joseki archive repo. remote-v. Yeah, so you can see this here. So I wrote a bunch of scripts to figure things out and then go from there. I guess I should talk about the Git roots first, because that was actually the first thing that one of the main things that was really frustrating with this repository is it was really difficult to follow the history. Something about multiple unrelated histories and many Git roots confuses git log, which is, I use git log all the time. So for instance, hold on, let me find one of the roots. Max parents equals 0. This is the 5 roots. Is this one? No, that's not this one. Yeah, okay. So for instance, this file, normally in Git, you can do git log -- and then a file name, and it'll tell you the commits that changed that file. Unfortunately, for some reason, I haven't really figured out why, when there are multiple git roots, Git just doesn't do this properly. There is like a git log -- all, which is supposed to do it, but even that doesn't find this, which I find really annoying. And I never figured it out. But this alone is a reason for me to think, oh, while rewriting the history, I should probably try and eliminate all the git roots and just get down to a single root. That way it looks more like a normal repository, and we're taking this opportunity to rewrite the history, might as well fudge some things to make it look a little bit better. Now, unfortunately, there's 5 roots, and so I wanted to try and figure out what's going on in all 5 of those roots, and so I actually spent like hours and hours painstakingly tracing all of the merge commits that introduced new roots. I do have a funny command for that, which is not that one, this one. Git log -- merges, and then an xargs to see if the merge space of each of the parents is disparate. So if you fail to find a merge space between your 2 parent commits, that means you've introduced a new root. Or at least that was my intuition here. So this allowed me to find all the merges, and so I mapped those out as these little M commits. I just annotated these however I wanted. And then R was my root commits. The bold one is the one that I wanted the new root to be. And any of these P commits were just parents, because that was easy for me to reason about. And I annotated all of them over here because I spent a lot of time staring at this. And interestingly, when I mapped out all of the root commits, I noticed a few things that were really helpful. For instance, first off, this merges backwards. This merges backwards. By backwards, I mean typically in a Git repo, the first parent is conventionally supposed to be your mainline history. And so what this should look like is a bunch of merge commits and then a bunch of things, sprawled out to this side. But instead you see this like zigzag of merge commits and roots here. And when this is the actual root commit that we care about. So a few of these merges were backwards. And also I noticed that several of the roots were introduced and then immediately deleted. So for instance, this entire set of 2 roots here was merged into this commit here, and then there's actually a commit right here that deletes this entire subdirectory. And so the history was introduced and then deleted, which tells me if my goal is to just preserve the history of the relevant things in the repository, I don't really care about deleted things, so I can delete this entire branch of history. Same is true for this, but this was more recently deleted and a lot smaller. This box right here actually represents like 80% of the bulk of the repository, and so just deleting this alone was a pretty significant change here. But yeah, the first thing that I did was map out all of the Git roots because they pose some problems. I did have to make this Git root still exist, and I'll show you that later. I actually turned this root into a branch that merges back in. And so it just looks like a feature branch that introduced this particular subdirectory. But I ran into a bunch of problems with this, so I'll show you that in a second. But yeah, mapped out all of the roots. I think that's all I have in Git tabs. Oh yeah, use pre-commit, good. And so let's walk through the script that I use. So I have a virtual in here. I have pip freeze. I have installed git-filter-repo. This is the tool that I used primarily to do this repository rewrite. Git-filter-repo is a destructive change. It is going to rewrite your history. It is going to require everyone to reclone or refork or etc. Like this is a destructive action, and we chose to do this destructive action because we figured we got one shot to make this good. Let's do it right, and we'll be able to move on and keep leave the old history behind and move forward with something that's a clean slate. And another thing that I used throughout this, this was my find all of the root commits and then try and graph them terribly. Does it still work? Yeah. So for instance, it takes a while because finding the merge commits that have no parents. Yeah. So this is supposed to look somewhat like this nice drawing here, but of course I couldn't be bothered to try and write like a tree drawing algorithm. So it's close enough. It was helpful for me. It wasn't, exactly what I needed, but the other thing that I used a lot was this script here, which I found from Stack Overflow. So if you want to see this Stack Overflow link, blazingly fast shell one-liner. This was helpful for me to find large objects in the repository and figure out their paths, and then eventually figure out whether I need to keep them around or not. And so this this was really helpful to figure out, well, there's obviously a lot of really small files, but you can see that there's a lot of really, really large files. And so targeting these specifically helped me reduce the repository size a lot. For instance, 113 megabytes, no, 153 megabytes of the repository is just Webpack cache that somebody accidentally checked in. Like these are things that were very easy, low-hanging fruit to target first. And so I went through some of these and targeted other stuff like that. Also checking in the PyTorch compiled output many, many times. Things like that. This was really helpful for figuring out what was big and then what sort of things to try and target when rewriting the history. Okay, so that's most of the ancillary side scripts. I also have this what uses v1 script. It's not easy to explain what's going on here, but I figured out, this was actually how I could figure out that this red block was able to be deleted. I basically checked out the last revision of this red blob, and then I found every file blob, the hash for it, the git hash for it, in this section here, and wrote it out to a file. And then I wanted to see if anywhere else in the history any of those blobs existed, except for the empty blob, because obviously, init.py, empty file, I don't really care that it's present in the other history. Also, nice. But yeah, I was basically able to, this script was to prove to myself that I could delete this and without caring about it. And fortunately, after running it, it took like an hour because I didn't try and optimize it. I just ran it and went for a walk or something. I found that there were, almost no files that were carried forward in the history that weren't in this v1. There were a handful that were like GitHub Actions or like READMEs or like, example.txt with hello world in it, things like that, which I figured, that file will still be preserved, but it's not important to say that it came from this entire branch of history here. So that's what this script was. And now we get to the big one, rewrite.py. And I'm going to walk you through all of the various steps that I took in this script. It's pretty long, but there's some instructive stuff in here that it took me a long time to figure out. And if you're doing a process similar to this, then maybe you'll do this as well. Oh, also, I guess there's this download all release assets. Just in case somebody wanted something from the repository releases, I downloaded every asset. Because part of this process, we determined none of the tags were tagged on anything relevant. In fact, like almost all of the tags were in this red blob. There were actually a few dangling tags. Ones were like, well, I wouldn't call them dangling tags. They were tags that were branched from this history. Sort of backport-like tags. And actually those posed a lot of problems in that if I wanted to rewrite just a subsection of the history, I would also have to rewrite every tag that forked from it. And I'll show you that later, but we ended up just deleting all the tags, which simplified all of that entirely because none of the tags were useful, which also meant we were deleting all the releases, which is why I archived all the things here. Okay, let's get into this rewrite.py. Yeah, so I guess I'll show some of the, oh man, there's a lot of stuff here. There's a lot of helper functions here. Most of them are around like running a subprocess or running the subprocess and getting its output, changing into a directory, just showing, trying to make a debuggable script. Finding a commit based on its commit message. This was the only way that I could consistently target particular commits. So that is also why, for instance, I've annotated this commit, this parent commit. Rename dot to Joseki _v1, for instance. Yeah, and then we'll talk about the other commit, the other helpers later. But for the most part, this is a script where I delete the repository and then I copy over. Oh, wait, I have this wrong. Okay, I was gonna run it too, so let me do that. Move this to original. And the script takes a little while to run, so we're gonna run it in the background while I talk about it. I say it takes a little bit to run. It's like a minute, whereas initially it was taking like an hour. So I improved this because I needed to iterate on a lot. So I figured I'll try and make some of the things more efficient. And then beyond that, I mostly just wrote a bunch of helper functions to perform the side effects that I needed, and did each operation in order. There's some stuff about this that I still don't understand, and it's okay for me not understand, but this operation should have been able to do anywhere in here at all, like any ordering here. But I ran into some weird bug with git-filter-repo where it just crashed on some error message that I have no idea what it meant. And there are some duplicates in the repository and like a reproduction, but I think this tool, like, while it's still useful, it's not really being actively developed. So this bug may happen forever, but whatever. I eventually figured out that if I reorder these operations in a particular way, then it avoids the bug. So I think the reason that this being later worked is Squash PRs deletes about half of the objects in the repository, and so maybe it's just like an object count problem. I don't know. Anyway, let's start with the start, which is delete other refs. So this is what I was talking about before, where I'm just going to go through and delete all tags. I don't need to rewrite the tags because we're deleting them. This also, I also deleted the remote. That way I don't accidentally do any destructive actions to the remote yet. We eventually force deleted all the tags in a separate, just ran it on the command line. And I think that's actually at the bottom of this issue here. Yeah, I made a run book here. Yeah, I made a run book. that way I wrote everything down, and we made sure that like air traffic control, I was sitting next to Jason, and we're like, okay, this is the command we're gonna run now. Does that make sense? Yes, run it. Does this command make sense? Yes, run it. Does this command make sense? Yeah, run it, etc., etc. That way, it wasn't just me destroying this repo. But anyway, okay, so let's start with, we already delete other refs, good. What's the next function? Rename MTLLM. Okay, this is where I have to use my diagram to explain things. So this branch, or this root here, a product was merged into this repository that was called MTLLM. And at some point, this MTLLM got renamed to Jack by LLM. That part's not important. The part that's really annoying about this is the root of this history started at dot and then eventually moved to a subdirectory. And git-filter-repo does, as far as I know, does not have an easy way to do just that root to something rename on a subsection of the history. You can run it on the whole history, like you can move every part of the history to another part, but I couldn't find a way to target just a specific, well, in this case, a specific branching root of the repository. And so what I ended up doing, or what I ended up making, is a little helper that allows me to take a commit and check out a branch, and then only run the rewrite command on that particular branch, and then replace that branch back in. And so that's basically what this helper does here. Figures out the commit ID of the thing passed in, checks out that branch to a particular name, gives a command to run git-filter-repo. Originally, this git-filter-repo command was a lot more complicated because you actually, like, if this branch here had, or not branch, I mean it is a branch, but like if this section of history had tags that were attached to it, especially ones that were not part of the history itself or were annotated tags, those wouldn't be picked up by this git-filter-repo command here because it's only running against head. And so I initially had to find all those tags and run it here, but once I deleted the tags, I didn't need to do that anymore. And then this is the operation for replacing a single commit in the history with git-filter-repo. So you basically call git replace. This says this SHA should become this SHA, and then you run git-filter-repo, and it does its magic to get rid of the old ref and replace it with a new one. But basically, this context manager was a way for me to check out a branch, perform some rewrites on that branch, and then merge it back in. And this is the only way I could really figure out how to run git-filter-repo on a subsection of the history. I think this was kind of the big aha moment is figuring this out because it made every other rewrite a lot easier. Okay, so I guess I should talk about why did I want to rename dot to its eventual subdirectory. And this was kind of for two reasons. One, when looking at git log, I would no longer need to traverse a bunch of renames. This repository has many, many commits where it's just like, take large chunk of history, move it to a different location. This makes it hard. One, if I want to delete binary files that existed across that merge, I now need to delete them at two places. But also two, if I want to track the git history for any of those files, I have to use, -M3 or -M3 and like make sure that git log traverses the moves. But if I just magic them, if we're going to rewrite the history, might as well just magic them to appear in the place that they are eventually going to appear in the final repository. And so I did a lot of those rewrites on subsections of the history to make them appear like they were at the place where they were eventually going to live. And so this was one of those, one of many, where I basically moved the MTLM root history to exist at its final resting place at Jack MTLM, a subdirectory in this monorepo. And we're going to see that a lot of these. Now, some of these commit messages are a little bit silly, like this one was just big move. For instance, rename Jack Cloud. Jack Cloud is actually this part here, and then was deleted. However, again, it's really hard to target files that are just in the root of the repository, and so renaming it first and then deleting it was a lot easier. So again, I used this to subdirectory filter. This is a shorthand to take the root of the repository and move it to a subdir. In the same way that this big blob here, again, started at the root and then moved to _v1, and then I believe Jaceki _v1. And so, for instance, I did that here. Found the commit, rewrote its parent to rewrite. Oh, I had to do two rewrites here. I had to delete these files. They eventually got deleted in a later commit, so I decided to just rewrite them in the current commit, and then do another to subdirectory filter. So a lot of the first part of this history rewrite is just taking everything that started at the root and putting it at its final resting place. Okay, I believe we actually get to the fun stuff next. Also, throughout this, you'll note that I'm running git-filter-repo many times. Ideally, you can get to a place where you only have to run it once, but due to the complexity of this history, due to just sheer amount of clusterfuck of nonsense going on here, I had to do a lot of these things. A lot of calls to git-filter-repo. Okay, I guess these are in order. Cool. Next is trailing rewrites, which I believe at the time that I wrote the function, it was the last thing that was happening, but I eventually wrote more things after. This was just a laundry list of files that I knew I could delete, things that didn't end up in the final repository. Sometimes they didn't really contribute much to the repository size, like a bunch of GitHub actions aren't going to break the bank. But I knew they were going away, so I might as well just delete them. V1, this is that entire sub history here, this entire block here. A bunch of random large things like some big PNGs, some checked in compiled images, a VS Code extension, some GIFs, some MP4s, just general large things. A poetry lock that ended up going away. Some PNGs that PNGs in trench coats, SVGs that actually just had PNGs rendered inside of them. I also found a bunch of files that didn't really make sense or just like accidentally committed, like a file that was parentheses busy parentheses. Some other stuff that was deleted, some compiled output, and a lot of stuff. This is just delete all these things. This also did a bunch of path rewrite renames at the same time. So for instance, there was a big rewrite that renamed jacklang to jack. There was a big rewrite that renamed Jaceki v1 to _v1. There was the rewrite of jack mtlm to jack bylm. And so I was able to just bulk do these all at the same time. Yeah, I'm sort of, the function name doesn't do everything that it says it does. It's kind of, again, this was the big command that I was trying to get everything down to one invocation of git-filter-repo, because it runs a lot faster if you just do one at a time. But couldn't really do that, so a hodgepodge of things. And this is write once code, so I wasn't trying to make it perfect, even though you'll notice I have type annotations on all this, and like I was running linters and iterating, and I didn't write any tests. Well, I did write a few tests at the top of the file, but nothing too involved. Yeah, another few things that I had to do. There was a file with a control character in it, so I didn't have a good way to target it, but with a glob, you can just, t.replace random control characters. This file moved around a lot, so I just said, screw it, I'm gonna target it with a glob. This was a bunch of files that I could just target all at once rather than enumerating them all. These files got merged or moved around a bunch of times. Very annoying. Yeah, trying to follow all the moves in this repository was making my head spin. And then finally, invert paths. Like whenever you're targeting a bunch of paths, and then invert paths. Basically, this just says delete all these things, which is really helpful. Okay, next is squash PRs. This I actually showed off in another YouTube video. What was the title of that video? It was kind of a cool one. I really liked the video, but this one, yeah, I think it's in this one. I showed off this squash merge idea, where this allows you to take any merge commit and then convert it back into a squash merge just by removing the second parent. And again, conventionally, the first parent is the mainline, second parent is the merged branch. And I specifically was targeting ones that were GitHub pull requests. That way I would preserve any merges that were just merges for the sake of merges, but this would squash any pull requests. And so this reduced the history size by a lot because there was a lot of merge commits that introduced files that got deleted. So even though they didn't appear in the final output, they were in one of the intermediate steps. Let's continue onwards. Okay, here's another subdirectory rewrite. This was the root of the repository got moved to Jack. This is actually the real root of the repository, this one here. I believe that's this commit. Yeah, no, this one, I don't know, one of these commits called bringing Jack Lang over. And I was, again, checking out a subsection of the history and then doing a rename. I did do a few other things here where like the .github folder, because of this rewrite here, the root became jack/.github, but we want to keep the GitHub actions at the root of the repository. And I actually had to undo a double rename here because this actually made jack/jack, and so I had to put it back to jack/jackling. This commit here actually has a mistake in it that was fixed later, and so this is actually me just preemptively fixing that mistake. Next we get into some more wild nonsense. I will explain this in a second, but this is where I actually veered off script and stopped using git-filter-repo because I couldn't figure out how to use it properly in this case. And this is talking about vendoring a subsection of the repo. So for a while, the Jaceki repo vendored, where does it live? Vendor? Yeah, vendored a, well, has a bunch of vendored things, but in particular, it vendored typeshed. And if you're not familiar with typeshed, this is like type annotations for type checkers and stack analysis tools. And this repository is pretty large. And a vendored copy of it is annoying for two reasons. One, it's large, and two, it uses all sorts of common variable names. So if you're searching a repository, you're often going to hit these files. And I found it really annoying to deal with, and so I managed to convince the maintainers of the Jaceki repo, hey, we should probably just represent this as a submodule. This will make it easier. One, easier, more transparent to update. Two, harder for somebody to accidentally edit it. And three, we can reduce the particular problems with like grepping and repository size, or at least defer them to a submodule. Technically, a submodule actually increases the clone size of a recursive clone, but yeah, 6 of one, half dozen the other. I felt the other benefits were worth it. But for some part of the history, this actually just existed as a directory and all those files splatted in there. So what I wanted to do was rewrite the history such that the submodule just always existed there. And I'm sure there is a better way to do what I was doing, but I found the particular commit that introduced it. I used git rebase with a custom editor that is just sed to the set expression does find the first line, look for pick, and replace it with the word edit. This is basically in an interactive rebase, I'm changing the first operation to edit instead of pick. Obviously, there's probably a better way to do this, but I didn't know, and this worked after some fiddly bits, and eventually got there. And so then what I did while it's editing this is delete typeshed, add typeshed, set it as this revision. This was actually the revision at about the time this merge commit was introduced. So I tried to match it one-to-one, and it had all the same PI files in it. So I picked this revision. The revision actually updated when the submodule got reintroduced. Yeah, and then add the submodule, amend it, and let the repository history continue. Actually, now that I think about it, I bet I screwed up this commit, because an amend will actually set me as the committer and the commit time incorrectly. So I bet if I find this commit, that's annoying. Let's see. Oh, I guess it takes 3 minutes. Okay, well. Oh, and it didn't even work. Why didn't it work? Oh, because it ran pre-commit. Yeah, so let's rerun this again. Anyway, I bet I screwed up the committer, but that's what this is for up here. So a thing that I didn't realize about rebase is if you rebase some history, so let's actually just take a random repo. This is gonna be a long video. Sorry about that. Or you're welcome, whichever you like. If you like long videos, then yeah, tokenize RT. So for instance, if I show this commit, git show format equals %ct cd, yeah, you can see this commit was committed on Tuesday, May of 27th of 2025. If I were to rebase this history, and of course, well, I'm gonna just so I don't make any mistakes here, rebase -i this, and let's say that I don't know, edit this one for some reason, and I think this is enough to make it rewrite. Oh no, probably not. Dang it. Did this actually rewrite? I don't know. Let's just take one of these. Git show format equals %cd this. Yeah, okay, so this did actually do a history right here. And so an annoying side effect of running rebase is it's gonna reset the commit time. And so it's gonna look like the entire repository was committed when I ran this rewrite script. Now, technically, yes, it was committed when I ran this rewrite script, but I wanted to preserve the original commit time so it looked like the repository history still continued in place. I also wanted to preserve the original commit author. So for instance, if I do %CA, no, what is the thing? Format. What is author? There it is, down here somewhere. Oh, %. No, I want committer. So it's gonna be CN. Yeah, so the original commit might not have actually been this committer. It probably was actually GitHub. No, it was probably me, but anyway, rebase resets both commit date and commit author. And I wanted to preserve those because that way it didn't look like I committed the entire repository. And so that's what this crazy git environment variable is here. I'm just going to tab it out so you can see it. But basically what this does is after a rebase, it reruns git commit amend no edit to reset the commit date, commit author, name, and email back to their original values. And so this I found this at the last minute on some GitHub gist. I wish I preserved the link, but I didn't for whatever reason. But this allows you to actually I had to change their thing because I had to do allow empty as well because sometimes there were empty commits. But this preserves the committer during a rebase. And so that's, whenever I had to use rebase in the script, I needed to make sure that I used this option here. I should have used it here. Don't know why I didn't. Probably just I didn't think about it. But you'll also notice more jank from this rebase. Again, I'm automating an interactive rebase, so I'm already doing something wrong. But the rebase actually conflicts with the eventual introduction of the submodule itself. And so you can see here, like, I'm making sure that I'm resolving the correct conflict and not actually doing something else. And so this is just like a little test, a little assertion in the middle here. But then I forcibly check out the correct revision and tell it to continue onwards. And so this was how I rebased out the type shed vendor, which I think is kind of cool. There's definitely a better way to do this, but this felt like a good way to do this. So yes. And then after that, there's more things to delete. This was, I think, ordered this way because I had already like rewritten some history in a way, and then this was simpler in this order, but it could have been done in any order. And next we get into our one git root. And so if we look at our diagram again, I've managed by this point in this script, I've managed to delete this git root, these two git roots, but not this one. And so what did I want to do? I wanted to represent this merge here as actually a merge from the commit here going to this root and then going to this history. So basically stitching that root back into the original history. The problem with that is by default, if you just like attach this commit over here, it looks like it deletes all the files and then recreates all the files. Because this tree here, I basically need to merge the trees. I need to do a merge and then a merge, and then an unmerge, and then a merge. But I needed to basically represent this tree on top of this tree rather than as two separate ones. When I say trees here, I mean Git keeps track of all of the files in a repository. And so this one had a Jack subdirectory, this one had an MTLM subdirectory. But I needed this commit to instead look like it had a Jack and an MTLM subdirectory, because that way it looks like it's just introducing this directory, some history progresses, and then that merges into the main line, rather than it being a separate root. And I'm sort of amazed that I managed to get this down to just one command here, but it's actually not that bad. So I found the merge commit, again, this pink one up at the top. And I was, again, making a branch of some sub-history of the repository because I was going to rewrite that history. And then I rebased, and this is an option that I learned. Rebase merges equals rebase cousins. I believe this is necessary because I was rebasing a history that was unrelated. But without this, it just deleted all the merge commits, and I didn't want that. There's like 3 other options to rebase merges, and none of them did what I wanted. In fact, the other ones I think just crashed. Probably a bug in Git, but I don't know. And I'm rebasing it onto the first parent of this commit. So I'm rebasing it onto the last commit in this little section here. And that's it. Basically just rebase this, get the last git root eliminated. A cool thing about this is if we go to our final result here, also this is the output of the script. So you can kind of see the difference in git size after the rewrite, as well as the number of commits that it reduced it down to, and I put time so you could see it in the video. But if we git log grep this, it's this one. I don't know why I didn't find it. Oh, because of the quotes. One line, I think I don't need first parent. I think I want graph. So this is after doing that, the repo root rewrite. So the history on the right is the sub-history, the originally disparate history. And you can see here, like, I managed to make it look like a merge, or look like a fork from the previous commit that it was getting merged into. And so this commit looks fairly normal. It's just introduce the stuff in the subdirectory. Now note, originally this was at the root of that original history. So there's some other fiddly bits here going on here in that, like, I had to move the root out and then merge it in. So, but anyway, that's it. That's all the things that I did. And after doing that, I ran this runbook, which was to fork the repository, including branches, to a backup. That way, you know, the destructive operation is not going to go away. I clicked unfork on that just so that it was a separate repo. That's what this archive repo is here. We archived it. We're not going to make new commits to this, but you can still access it and retrieve things from it. Archived all of the assets in the current repository. That way, if we needed release assets, we could. I closed all existing PRs. I think in retrospect, I didn't need to do this. Actually, we left one open just to see. I had a hypothesis that if we did a rewrite of the main branch, that it would auto close the PRs, and GitHub did, which was nice. So I didn't actually need to do this step, but we did it anyway, except for one PR. We left one PR open because we were curious what would happen. Then I deleted all other branches except for main. This was again in line with the don't keep your own branches that potentially have junk in them. Deleted all tags. We didn't need the tags, so we got rid of them. Ran the rewrite, and then finally I force pushed over main. I actually had to run this twice because the first time I didn't have that rebase fix, and so it attributed every commit in the repository to the original author and me. Didn't want that, so actually ended up doing this force push twice here. And the result is a much smaller repository. I think as you can see here. So initially it was 628 megabytes, reduced it down to 480-ish by deleting branches. And then after deleting all the large stuff in the history and deleting these entire subsections of history, got it down to 21 megabytes, which is still too large, by the way. It's still too large. But it was a much more manageable section of history. There's still some fairly large PNGs in the resulting repository, but 21 megabytes is significantly better than what it was before. I don't know, as like a comparison, this repository here is half a megabyte, 600 kilobytes, you know, essentially nothing compared to that. But anyway, that's the history of history of how I took this absolutely massive repository and with a month of work, or a month and a half of work. I guess it wasn't really a month and a half of work. I probably only worked on it for a couple weeks, but reduced the repository down by a bunch and then prevented it from regressing moving forward. Oh my, this is a long video. Well, thank you all for watching. I hope you enjoyed this rambling nonsense about how I did this. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.